So this is the speed and velocity activity. This is task 5. We did this in class. We collected the data together, and then we went over this in class. So this is what we went over together in class. So for the pre-activity questions, they're asking about, number 1 says, what is the equation for the speed of an object? Well, speed equals distance divided by time. So it's the distance that you travel and the time that you traveled. And the next question is the equation for velocity. Now, the difference between speed and velocity is that speed uses distance, so it's a scalar quantity. It doesn't have a direction. It's just magnitude with a unit. For velocity, we use displacement over time. And remember that displacement requires a direction. So it's magnitude and direction. That makes it a vector. If displacement is a vector and we use displacement to calculate velocity, then velocity is also a vector. So number 3, what is a scalar quantity? It is a quantity that only uses the magnitude. It only has magnitude. So that's like if something is 50 meters, you don't say 50 meters west. If it's a scalar quantity, you would just say 50 meters. But a vector has a magnitude and direction. So then you could say 50 meters west with magnitude and direction. So of the ones that we've discussed so far, these 4 terms, distance, displacement, speed, and velocity, which of the following are vectors? So remember, we just said that vectors have magnitude and direction. Okay, so that's going to be displacement and then velocity. Those are the 2 vector quantities. Distance and speed are scalar. Examples of units that we use for distance, displacement, speed, and velocity. So I'm just going to give you the most common units that you'll see in problems. So meters for distance, meters again for displacement, but you would also want to include a direction. So I'm just going to put north. Speed is, remember we said to calculate speed, it's distance divided by time. So meters is a distance unit and seconds is a time unit. So meters divided by seconds, distance divided by time. Those would be units that we would commonly use for speed. And velocity, again, same units, meters over seconds, but again, you need a direction. So north, for example. And again, these are just example units. So for distance, you could also have kilometers or miles. Same with displacement. Speed, meters per second is what we have here, but you could also use kilometers per hour or miles per hour. Those are all units for speed and velocity. Okay, now this is what we actually did in class. So we walked around a square. So use tape to mark the corners of a square that you can walk. Measure the square so that each side is 2 meters in length. The first corner will be corner A. From corner A, the next will be B, then C, and D. Have someone walk around the square while another person times them. They need to complete the walks below in the data table. So I drew a square down here. And you can see, so this is what we set up in the hallway. We taped down just corners of this square. And we measured that each side was 2 meter sticks in length. So we walked from A to B. It was our first walk. The second walk was we walked A to B and then B to C. The third walk was we walked A to B, B to C, and then C to D. And then the last walk was all the way around back to A. And then while one of the students was walking the 4 walks, another person was timing them. Okay. So I'm going to put the times in here for if you were absent. This is the data that I put in the assignment. towards the bottom. So use this data if you were absent. So those are the times that I put in there. Number 3, determine the distance and displacement for each walk and record that in the data table. You will need to measure the diagonal of your square for the displacement of A to B to C. So remember, with displacement, you care about your starting point and your ending point. And for all the walks, you can figure that out just looking at the square, because you know that each side is 2 meters. But when we walk from A to B to C, A is our starting point and B is our ending point. So the displacement is this diagonal line that we actually had to measure. And we got that it was about 2.8 meters. Record the time in the data table. Now in the second data table, calculate the average speed and average velocity for each walk. Show your work in each calculation. So let's go ahead and calculate the distance and displacement for each of the walks. So from A to B, that one's pretty easy. The distance is 2 meters, and the displacement, you want to specify that it is 2 meters north. So the reason that these two have the same magnitude is because we walked in a straight line and we didn't change direction. So remember, when you walk in a straight line, your distance and displacement are the same. From A to B and B to C, the distance, you want to add up. 2 plus 2 is going to be 4 meters. And the displacement is this diagonal line that we measured from A to C. It's going to be 2.8 meters. Okay, and the direction is going to be northeast. Up and to the right is northeast. The third walk, A to B, B to C, C to D. The distance is going to be 2 plus 2 plus 2. That's going to be 6 meters. The displacement, you look at A and you look at point D, your starting point and your ending point. And you just look at a straight line between those 2 points. So we didn't actually walk along this path here, but that's our displacement. That's our starting point and that's our ending point. So our displacement is 2 meters to the east. And then for the last one, we went all the way around. So we want to add up all sides of the square. So 2 plus 2 plus 2 plus 2 is going to be 8 meters. And if we go all the way around, that means that we're going to stop in the same place that we started. And that makes your displacement 0. And remember, you don't have to put the direction if your displacement is 0. All right, for the second data table, it asks us to calculate the average speed of our walks. So we're going to take our distance divided by our time. So these are your distances here, because it's labeled in the data table. And these are your times, again, labeled in the data table. So you're going to take this number divided by that number. So 2 divided by 3. And that's going to be 0.67 meters per second. Second one, you're going to do 4 divided by 6. Again, that's going to be 0.67 meters per second. And you're going to keep going down. So 6 divided by 9 and 8 divided by 12. Again, each of those is going to be 0.67 meters per second. So looking at the speed, we can see that they're all the same. So that means that the person walking walked at a steady pace, at the same pace for each of the walks. And if you look, it makes sense because each time it goes up by 3 seconds. So they walked at the same pace for each of the walks. That means they walked at the same speed. Now for the velocity, we're going to take the displacement divided by the time. So we're still going to use the time, the last column, but this time we're going to use the middle column, the displacement column. So you're going to take these numbers and divide them by these numbers. So again, for the first one, it's 2 divided by 3. We talked about how the distance and displacement are the same when you walk in a straight line. So if you're walking in a straight line, that means your speed and velocity are also going to be the same. Don't forget to put direction on velocity. because velocity is a vector. You just use the same direction that you used for displacement. Because again, remember, we're using displacement to calculate the velocity. The next one's going to be 2.8 divided by 6. That's 0.47 meters per second. Again, for the direction, use the same direction as your displacement. A to B to C to D, that's going to be 2 divided by 9. That's going to be 0.22 meters per second. And this one's going to be to the east. And the last one's pretty easy. It's 0 divided by 12. So that's always 0 meters per second. Don't need a direction when it's 0. Okay, so those are your speeds and your velocities. Number 1, for the post-activity questions. Were the speed and velocity the same for each of the 4 walks above? So looking at the walks, we can look at the first one from A to B. We have 0.67 and 0.67. So yeah, those are the same, at least in magnitude, those are the same. Magnitude, remember, is the number. So those match. The second one, 0.67 and 0.47, those ones don't match. 0.67 and 0.22 don't match. 0.67 and 0 don't match. So really only the first one matches. And again, guys, that's because we walked in a straight line and did not change direction. So only A to B match. Because motion was in a straight line. Number 2, a car travels from point A to B in 3.5 hours and returns back to point A in 4 hours. Okay, so point A to point B. We go there and we go back. Point A and B are 150 kilometers apart along a straight highway. And A to B was 3.5 hours, and B to A was 4 hours. So that's something to keep in mind. Which of the statements most accurately describes the motion of the car? Circle 3. So there are 3 true statements here. I think the easiest way to do this is going to be to figure out the distance, the displacement, the speed, and the velocity. Once we know those, it'll be very easy to pick out the statements that are true. The distance is, we want to add up the trip there and the trip back. So you do 150 plus 150. That's going to be 300 kilometers. The displacement, we're going to start at A and then come back to A. So the displacement's going to be 0. Right? So if you start where you stop, your displacement is 0. So now we need to figure out our speed and our velocity. So the total trip took 3.5 hours plus 4 hours. So that's 7.5 hours for the whole trip. So to figure out the speed, we need to do the distance, which was 300, over the time, which is 7.5 hours. And so the speed is going to be 40 kilometers per hour. Squeeze that in there. Now, because the displacement was 0 kilometers, and to find velocity, we do displacement over time. If the displacement is 0, then our velocity is 0 as well. So now that we know the distance, the displacement, the speed, and the velocity, now we can look at our statements and figure out which ones are true and which ones are not true. So we want to pick 3 statements that are true. So the first one says the average velocity of the car is 40 kilometers per hour. The velocity of the car is 0 kilometers per hour. So that one cannot be true. B says that the total displacement of the car is 300 kilometers. The displacement of the car, we said, was 0 kilometers. So B cannot be true. Well, that only leaves us with 3 left. So that must mean that the next 3 are true. But let's go ahead and confirm. So C says that the average speed is 40 kilometers per hour. We calculated the speed over here, and we did indeed get 40 kilometers per hour. So that one is good. D, the velocity is 0 kilometers per hour. We just confirmed that one a second ago when we said that A was false, right? So velocity is 0. Velocity is 0. That is good. And the last one, the total distance is 300 kilometers. That was the first thing we figured out, that the distance was 300 kilometers. So that one is good. So the answers are C, D, and E for number 2. Number 3, draw a picture to assist. A person walks 60 kilometers north in 1 minute, then walks 30 kilometers east in 2 minutes, then walks 60 kilometers south in 2 minutes. Finally, they walk 50 meters west in 1 minute. So I drew this one out for you, and I had this on the board in class, so they didn't have to figure this one out. The reason is because this one was a little bit tricky. If you look here, this was our starting point, and at the end, when we go 50 meters west, we actually end up walking past our starting point. So if you look, we went 60 north and 60 south, so those cancel. We went 30 east, but we went 50 west. Okay, so 30 and 30 cancel, but we went 50, right? So this additional walk, the additional part of our journey, okay, from A to E is going to be 20 meters to the west, or 20 meters to the right, or I'm sorry, to the left. So this part right here is 20 meters west. You always go from the starting point to the ending point when you're looking at the direction. Okay, that's going to be important. We're going to need that for C, 3C. So B, calculate the average speed over the whole 6-minute walk. So 6-minute walk, that's how long it took. Okay, we had 1 minute, 2 minutes, 2 minutes, and 1 minute. So if you add those up, you get 6 minutes. To do the speed, we need to calculate the distance first. So to calculate the distance, all you have to do is add up your distances. So 60 plus 30 plus 60 plus 50. When you add all that together, you should get 200 meters. Okay, so that's the distance. Now we can calculate the speed. The speed is the distance over the time. So we're going to have 200 meters divided by 6 minutes. This is not a usual unit that we use for speed, but that's okay. We'll just use the units that we're given. So 200 divided by 6 is 33.3 meters per minute. Okay, so that is the answer for B, 33.3 meters per minute. And C says calculate the average velocity. So velocity, we need to get the displacement first. And so that's going to be up here what we figured out from A to E. Remember, displacement is how far away is your starting point to your stopping point. We only care about where we started and where we ended. So our displacement is 20 meters west. That's our displacement. So then we can calculate our velocity. That's going to be your displacement over your time. So 20 meters west over 6 minutes, the whole trip. It still took 6 minutes to go from point A to point E. So 20 divided by 6 is going to be 3.3 meters per minute. And then don't forget, we need a direction on velocity because it's a vector. So you just use the same direction that you had on displacement. So west. And there you go, 3.3 meters per minute west.